Hello students, so continuing our lectures on complex analysis. Uh, Now what we have previously discussed is that complex number is an ordered pair of two real numbers. Like A, B, so that makes a complex number Z is equal to A plus IB, and complex variable is actually ordered pair of two real variables. F means Fz is equal to Q xy, function of xy is a real variable, plus I into V x, which is also a variable. Now in this case, if you take the derivative of Fz, so we'll have limit z tends to 0, Fz plus delta z minus Fz divided by z plus delta z minus Fz, and this will again be equal to limit delta z tends to 0. This will be delta z, limit delta z tends to 0, delta z by delta z, and this is nothing but this is equal to df by dz, and which is dash z. Now z again is equal to x plus iy, so we take delta z, it will be delta x plus I delta y, and f, as we know, is equal to u plus iv, so delta f is again is equal to delta u plus I delta v, so delta f by delta z is equal to delta u plus I delta v plus divided by delta x plus I delta y. Now the limit can be taken, delta z is equal to 0. This limit can be taken in two different forms. For example, if we draw the y versus x plot, z is equal to x plus iy. So this is actually the real z, and this is actually the imaginary z. So any point say z0 is represented like this. So if this z0, if this tends to 0, or any change delta z tends to 0, so it can be approached in two different ways. First, delta y is equal to 0 and delta x tends to 0, or delta x is equal to 0, delta y tends to 0. That means that we can come to this line, come to this point in two different ways, either like this or like this. If this is equal to, if we are going in this direction, the red one, it means that here your delta y is equal to 0. Delta y tends to 0 and delta x is equal to 0. Or if we are following the green line, then here it is delta y is equal to 0 and delta x tends to 0. So there are two different ways of expressing the point. Due to this, when we are telling that limit delta z tends to 0 del f by del z, we are trying to find out this. So it can be written in two different forms. Firstly, so right here, limit delta z tends to 0 del f by del z is equal to either limit delta x tends to 0 then del u, and this is again equal to del u plus I del v plus del x plus I del y. So whether it is delta x tends to 0 del u by del x and delta y is equal to 0. So it becomes plus I del v by del x, considering delta y is equal to 0. So here, since delta y is equal to 0, so we are not considering this part. Similarly, we can write this is equal to limit delta y tends to 0 and delta x is equal to 0. Then it will be del u by del y with a minus sign, because there will be I here, plus del v by del y. So it will be again equal to limit delta y tends to 0 minus I del u by del y plus del v by del y. Now these two are equal. So if we compare these two, what we get is del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. So this is popularly known as the Cauchy Riemann condition for a function to be analytic. If these two conditions are satisfied, then the function is analytic function. So let us again come to the definition of an analytic function. Analytic function, if it says that if fz is differentiable at z is equal to z0 and in some small region around z0, then we say that fz is analytic at z is equal to z0. And if the function fz is analytic everywhere in the finite complex plane, then the function is then called an entire function. It's called an entire function. Now let us see some problems to find out whether the function is analytic or not. Suppose we have fz is equal to z square. Sorry. Z square. So we need to find whether it is analytic or not. So as you know, z is x plus iy. X plus iy whole square becomes x square minus y square plus I to xy. Now this is the real part and this is the imaginary part. So this we take as u and this we take as v, considering f is equal to u plus iv, and according to Cauchy-Riemann condition, del u by del x is equal to 2x and del u by del y is equal to minus 2y and del v by del x is equal to 2y and del v by del y is equal to 2x. So we can see that del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. So it means that the Cauchy-Riemann condition that we just derived, this one, is getting satisfied. Hence, we can say that the function fz, this is analytic. Let's take another example. If fz is equal to z star, means the complex conjugate. So if z is x plus iy, z star is x minus iy. So here we consider f plus uyy. So we can see that del f del u by del x is equal to 1 here, and del u by del y is equal to 0. Del v by del x is equal to 0, but del v by del y is equal to minus 1. So even if the first condition is satisfied here, so we can see that the Cauchy-Riemann condition that del u by del x should be equal to del v by del y, it is not being satisfied, although this one is being satisfied. So this is not analytic.